Okay, next. So reduction formula for definite integral. So actually we already learned reduction formula for indefinite integral. Okay na? Now integral 0 to pi by 2, integral 0 to pi by 2 sin power nx dx, sin power nx dx equal to n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on 1 by 2 into pi by 2 if n is even, if n is even. Okay na? n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 into so on 2 by 3 if n is odd. Okay na? If n is even, so we will get the result like this. If n is odd, like this. So here nothing is there. See, just n minus 1 by n. So subtract numerator and denominator by 2. Okay. So by decreasing, at last if you get 1 by 2, then multiply with pi by 2. Otherwise, at last term if you get 2 by 3, then stop it. Okay. Now I will give one example for this. So find the value of integral 0 to pi by 2 sin power 4x dx. Okay. Now see, so irrespective of this n is even or odd, irrespective of whether n is even or odd, just start it by n minus 1 by n. Just start it by n minus 1 by n. So n minus 1 means 4 minus 1 by 4, n minus 1 by n. Just then subtract 2 in numerator and denominator successively. So this is 4 minus 3. Yes or no? Minus 1, minus 2, minus 3. By here 4 minus 2. Numerator and denominator subtract by 2 successively. Yes? And now next what you will get? See, this is nothing but 4 minus 3 means 1. 4 minus 2 means 2. So you are getting 1 by 2. So if you get 1 by 2, what you have to do? Just multiply with pi by 2. That's all. Here no need. See, here you can't able to prolong with this, because if you make again subtract 2, then what you will get? 4 minus 5, which is the negative term. Okay now. So just stop it here. Then what is the value? This is 3 by 4. This is 1 by 2 into pi by 2. So which equal to 3 pi by 16. Okay, that's all. Here the caution is, see, the limits must be 0 to pi by 2. The limits must be 0 to pi by 2. Okay na? If it is not from 0 to pi by 2, suppose if pi is here, then you have to convert this into integral 0 to pi by 2 by using the property, integral 0 to 2a f of x dx. Okay na? Equal to, so 2 into integral 0 to a f of x dx if f of 2a minus x equal to f of x, otherwise 0. Okay na? So by using this property, you have to convert the given problem into integral 0 to pi by 2. You must be care about the limits. Okay. Okay. Now for cos. So integral from 0 to pi by 2 cos power nx dx. Okay. Now integral 0 to pi by 2 cos power nx dx is nothing but integral 0 to pi by 2 cos of pi by 2 minus x power n dx. So which formula here, which property we are using here? Integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. Okay na? Now this is nothing but integral 0 to pi by 2, okay, cos pi by 2 minus x, which is nothing but sin power nx dx. Okay na? So this result is true for both sin power nx as well as cos power nx. So this is equal to, okay na, n minus 1 by n, n minus 3 by n minus 2, so on, 1 by 2 into pi by 2 if n is even, n minus 1 by n, n minus 3 by n minus 2, so on, 2 by 3 if n is odd. Okay na? Now I will give one example on this. Okay na? Okay, so let us give one example. So find the value of integral from 0 to 2 pi, integral from 0 to 2 pi cos power 5x dx. Okay. Now see, here the limits are given from 0 to 2 pi, 0 to 2 pi. Okay na? So now first of all you have to convert this into 0 to pi by 2. Okay, 5. So cos 2 pi minus x equal to cos x, cos 2 pi minus x equal to cos x. Okay na? So this becomes 2 into integral 0 to pi cos power 5x dx, cos power 5x dx. Okay na? Again now cos pi minus x equal to minus cos x, cos pi minus x equal to minus cos x. So then what is the value of this one? This is nothing but 2 into this value becomes 0. Yes or no? This value becomes 0. So this is equal to 0. Okay. See, first of all you have to convert this into 0 to pi by 2 form. So for that purpose I am applying the property integral from 0 to 2a f of x dx property. Okay na? So cos 2 pi minus x equal to cos x. Okay na? So 2 into integral 0 to pi cos power 5x dx. Now again this can be written as 2 into pi by 2. Okay na? So cos pi minus x equal to minus cos x. So the value of this one is 0. Fine. So I will give one more example. So integral from 0 to pi by 2, okay, cos power 7x dx, cos power 7x dx. Okay na? Now so the limits are 0 to pi by 2, so no problem at all. Now start the successive reduction. Okay na? Now n minus 1 by n, that is 7 minus 1 by 7 into 7 minus 3 by 7 minus 2 into 7 minus 5 by 7 minus 4. Okay na? So what is the value? 7 minus 5 is 2, 7 minus 4 3, 2 by 3. So that is the last term, just stop it. Okay na? So this is 6 by 7 into 4 by 5 into this is 2 by 3. Clear? So 3 ones are 3 twos are. So it's equal to, so 2 4 is 8, 2 is 16 by 35. Okay, got it? Okay, so next Wallace theorem. So integral from 0 to pi by 2 sin power mx into cos power nx dx. Okay, so the value of this one is depend on m and n. Okay, na? So if n equal to 1, this is sin power mx into cos x dx, which is of the form f of x power nx into f dash x. So x power n plus 1 by n plus 1 form. So then you are getting sin power m plus 1 x by m plus 1. So sin pi by 2 is 1. So 1 by m plus 1. It's easy, no problem. Next, coming to here, this case. If m equal to 1, then also this is of the form integral f of x power n into f dash x. So you will get 1 by n plus 1. Now, coming to this case, if n is odd, m may be odd or even. M may be even or odd. There is no restriction on m. If n is odd, then the reduction for this one is, see, you start from n always. So n minus 1 by m plus n. N minus 1 by m plus n. So successive reduction, that is make difference of 2 in numerator and denominator successively. Okay, so n minus 1 by m plus n into n minus 3 by m plus n minus 2. So continue this. So once this is stopped somewhere, because if you again apply successive reduction, then it becomes 0 now, 2 minus 2 0. So you should not continue the successive reduction. Just stop it here. Then at last 1 by m plus 1. 1 by m plus 1. So when this case is, if n is odd, irrespective of the m value. Okay. Now suppose if m and n both are even, so start the same reduction, that is n minus 1 by m plus n, subtract 2 in numerator and denominator successively. Okay, once stop this reduction, then start reduction for m, that is m minus 1 by m. Again, so subtract 2 from numerator and denominator. So m minus 3 by m minus 2. Okay then. Here actually you will get 1 by 2 here. Once if you get 1 by 2, then at last you have to write pi by 2. Okay. Now if m is odd, n is even. Okay now. If m is odd, n is even. See here n is odd, there is no restriction on m and n. But here n is even, m is odd. Then start the same reduction. But last term is 2 by 3. So just stop it. Just like in integral 0 to pi by 2 sin power nx dx. Okay? Fine. So actually no need of remember this total formula. You have to remember the process. That is when this type of problem is given. Okay? You have to start the reduction from n minus 1 by m plus n. Once this is completed, then start for reduction for m. Okay? So I will give one example on this. Okay, let us take one example. So find the value of integral from 0 to pi by 2 sin power 4x cos power 5x dx. Okay, here m is even and n is odd. Okay, n is odd. So take a reduction. So you have to start from here n minus 1 by m plus n, that is 5 minus 1 by 4 plus 5. Okay, into 5 minus 3 by, this is 4 plus 5, 9. So 9 minus 2. Okay. Now this is it. 2 by 7. 2. If you continue the reduction, this becomes 0. So just stop it here. Now n is odd. Here n is odd. So if n is odd, irrespective of the m value, okay, what you have to do? Multiply this with 1 by m plus 1, that is 4 plus 1. Multiply 1 by m plus 1. So which equal to 4 by 9 into 2 by 7 into 1 by 5. So which equal to 8 by, okay. So this is, so 35 into 9. So 45. So 315. Yes. Okay. Now maybe suppose if you won't remember this formula, I mean there may be some confusion. Okay. So this problem can do in another way also. Okay. So I will do here. So this can be written as integral 0 to pi by 2. Okay na? So sin power 4x. Yes. This is cos power 4x into cos x dx. Okay na? Now integral 0 to pi by 2. This is sin power 4x. This can be written as cos power 4 can be written as 1 minus cos square x whole square, that is 1 minus cos square x into whole square, okay na, into cos x dx. Clear? Now so let us consider sin x equal to t. Sin x equal to t. Cos square, sorry, 1 minus sin square, cos square na, so 1 minus sin square cos square, okay. So let us consider sin x equal to t. So cos x dx equal to dt. Now what about the limits? The limits become, if sin 0 0, sin pi by t is 1, okay. Now this equal to t power 4 into 1 minus t square whole square dt. Okay. Now this is integral 0 to 1. So t power 4 into 1 plus t power 4 minus 2t square dt. So this equal integral 0 to 1 t power 5 plus t power 4 t power 8 minus 2 t power 6 dt. Okay. Now make integration, which is t power 5 by 5 plus t power 9 by 9 minus 2 into t power 7 by 7 from 0 to 1. So substitute the value 1 by 5 plus 1 by 9 minus 2 by 7. Okay. And now simplify this, you will get this answer. Okay now. So this is the another process. See, but it takes a lot of time. Okay. So that is the use of this Wallis formula. Okay. Okay, so let us give one more example on this Wallis theorem. So find the value of integral from 0 to 2 pi sin power 4x cos power 6x dx. Okay. So when you are applying this reduction formula, okay na, you must be care about the limits. Okay na. So here the limits are 0 to 2 pi, but actually in reduction formula our limits are 0 to pi by 2. Okay na? So you have to convert this from 0 to pi by 2. So for that purpose you have to check whether the function is, so what is the given function? F of x equal to sin power 4x, okay, cos power 6x dx. Okay. Now f of 2 pi minus x, f of 2 pi minus x. Okay. Sin power 4 2 pi minus x, cos power 6 2 pi minus x. Okay. Now this is equal to sin 2 pi minus x. Sin 2 pi minus x, which quadrant? Fourth quadrant. So which is negative. But sin power 4 is there. So sin power 4x. This is cos power 6x. So that is equal to f of x. Okay. So the problem can be written as 2 into integral 0 to pi sin power 4x cos power 6x dx. Okay now. Now again this can be written as 2 into integral 0 to 2 into pi by 2 sin power 4x cos power 6x dx. Okay now? Fine. Now this is equal to, so check this property, f of pi minus x. F of pi minus x equal to sin power 4 pi minus x cos power 6 pi minus x. Okay na? So this is equal to sin pi minus x, sin x. So sin power 4x. Okay na? This is cos pi minus x minus cos x, but power 6 is there, even power. So cos power 6x, which is equal to f of x. Okay. So the integral becomes 4 into integral 0 to pi by 2 sin power 4x cos power 6x dx. Okay. Now this is in the form of Wallis theorem. Okay na? Now apply the Wallis theorem. So this is equal to 4 into, so the reduction start from n minus 1 by m plus n, that is n minus 1, 6 minus 1, 5 by m plus n, 4 plus 6, 10. What you have to do? You have to subtract numerator and denominator by 2. Okay na? So 5 minus 2, 3, 10 minus 2, 8, next 2, 3 minus 2, 1, 8 minus 2, 6. Once this is over, then you have to start reduction for m, because both are even, m and n are even. Start the reduction for m, that is m minus 1, 3 by m, 4. So 3 minus 2, 1, 4 minus 2, 2. If you get 1 by 2, what you have to do? Multiply this with pi by 2. Multiply this with pi by 2. Okay. Now 4 will be cancelled. 3 1s are 3 2s are. Yes. Now this is equal to 15 pi. 15 numerator and 15 pi by. So what is the value in denominator? So 2 2s are 4, 8. Okay, still it is simplified na. 5 1s are 5 2s are. Okay. Yeah, 5 1s are 5 2s are. 5 1s are 5 2s are. Okay, fine. Now numerator 3 pi. Denominator, so 4, 8, 16, 8 128. Done? Okay. So 3 pi by 128. Okay. So now one more problem. So find the value of integral 0 to pi x sin power 7x cos power 6x dx. Okay now this is of the form integral 0 to a x f of x dx. Okay. Now in 11th property we discussed that if f of a minus x equal to f of x. If f of a minus x equal to f of x, then this becomes a by 2 integral 0 to a f of x dx. If this property is satisfied only. Now, what is the f of x here? So, here f of x equal to sin power 7x cos power 6x. Okay, cos power 6x. Now, what is the a value? A value is pi. A value is pi. So, check it. F of pi minus x. F of a minus x. Okay, na? Equal to sin power 7 pi minus x cos power 6 pi minus x, which equal to sin power 7x cos pi minus x minus cos x, but power 6 is there, even power. So, cos power 6x, which equal to f of x. So, by this property, this becomes, okay, this becomes integral, so a by 2, that is pi by 2, a by 2 means pi by 2 integral from 0 to pi f of x means this one, sin power 7x cos power 6x dx. Okay. Now, in Wallis theorem, to apply the Wallis theorem, this limit must be pi by 2. So, now apply the property of integral 0 to 2a f of x dx. Okay, na? So, that becomes f of 2a minus x equal to f of x here. Okay, na? So, this becomes pi by 2 into 2 into 0 to pi by 2. Okay, sin power 7x cos power 6x dx. Okay, na? Now, this is equal to, so 2 will be cancelled. So, pi into, so apply the Wallis theorem. Now, start the, here n is even. Okay, na? So, just start the reduction from n minus 1 by m plus n. So, that is 5 by n minus 1, 6 minus 1, 5 by 7 plus 6, 30. Next 5 minus 2, 3 by 11. Okay. Again 3 minus 2, 1 by 11 minus 2, 9. Just next you can't able to make reduction. Okay. Then what you have to do? Now start reduction for m, that is 7 minus 1, 6 by 7, 6 minus 2, 4 by 7 minus 2, 5. Next 4 minus 2, 2 by 5 minus 2, 3. So 2 by 3, which is the last term. If 1 by 2, then only you have to multiply with pi by 2. Okay, na? Fine. So now this is equal to, okay, simplify this. 5 will be cancelled and 3 also cancel. Yes. 3 2s are 3 3s are. Okay. Anything else? Yes. Now 16 by 16 pi by, yes, 16 pi by denominator 7 3s are 21, 7 3s are 21 into 11, yes, okay, into 13. So 3003, okay, 3003. That's all. Okay, na? Okay, so next we will discuss Norton-Leibniz formula. Okay, so this is a very powerful formula to make differentiation or integration. Okay, to make differentiation or definite integration. Okay, now see what is this form is d by dx of integral from pi of x to psi of x f of t dt equal to, see, actually integration is reverse process of differentiation. So just you remember like this, the differentiation and integration both are anti, so both will be cancelled. Just keep it in mind, okay now. Then this becomes, you have to apply the fundamental theorem of integral calculus, f of b minus f of a na. So f of psi x into derivative of this one minus f of b minus f of a na. So f of pi of x into derivative of this one. So it's very simple. Just remember fundamental theorem of integral calculus. Integral a to b f of x dx equal to f of b minus f of a, like that. Okay. And now you may get some doubt. See, this is the function of f of t, but we are making a differentiation on x. How it is possible? But actually, this is not a function of t. Okay, now here we are using the variable t, but limits are functions of x. So this function becomes in function of x. So then you can make a differentiation. Okay, now. Now we will give one example on this formula. Okay, now. The problem is, if f of x equal to integral from 1 by x to root x sin t dt, okay, then find f dash 1, f dash 1. So this is the problem. Okay, now. So to find f dash 1, first of all you have to calculate f dash x, then only you can find f dash 1. Okay, now. So now you have to find f dash x. Okay, now. So therefore f dash x equal to d by dx of integral from 1 by x to root x sin t dt. Yes. Now by using the Norton-Leibniz formula, this becomes sin root x, okay, f of x into psi dash x, the derivative of root x, minus sin 1 by x into derivative of 1 by x, okay, clear? Now this is equal to sin root x into, so the derivative of root x is 1 by 2 root x minus sin 1 by x into the derivative of 1 by x is minus 1 by x square. Clear? And now what we have to find? We have to find f dash 1. So x equal to 1 implies f dash 1 equal to, this is sin 1 into 1 by 2 minus sin 1 into minus 1 by 1, which is minus 1. Okay, minus 1 by 1, which is minus 1. So this is equal to sin 1 by 2 minus into minus to plus, okay, sin 1. Okay, now which equal to 3 by 2 sin 1. Understood?